The announcement of Tesla's Cybertruck in 2019 stunned the automotive industry. Vehicle aficionados all around the world were excited awaiting this new truck, which had a design that looked like it came straight out of a sci-fi movie and an unending number of features that were designed to shake up the pickup truck market. Due to several manufacturing delays by Tesla, the enthusiasm for the Cybertruck has waned dramatically since then. But that is about to change, since Tesla has just received a high-end piece of machinery for the construction of the Cybertruck. Today, we'll look at the Hydra Group's incredible new Giga press and what it means for the Cybertruck. Greetings and welcome back to Tech Edge. In today's video, we'll look at the 9,000-ton Giga press, which has now arrived. But first, subscribe and enable alerts to ensure that you never miss out on such useful stuff. Some stories claim that the parts for the Giga press have already arrived. Tesla Cybertruck 9,000-ton Giga press starts arriving in pieces. According to The Driven, Tesla's 9,000-ton Giga press for making the Cybertruck has begun arriving in sections at the company's Texas facility. The equipment will be used to stamp big parts of the truck's body in one piece. Elon Musk, CEO of Tesla, has highlighted the Giga press as the key to creating an exoskeleton for the Cybertruck that is unlike any other vehicle. The Cybertruck has been postponed multiple times, and manufacturing is presently set to begin in 2023. Tesla's new Cybertruck Giga press is on its way, electric. The Giga press machine will be used to cast the whole body of the Cybertruck in only 2 parts, making it the first vehicle in the world to have a 2-piece body casting, according to Electric. During the last few years, Tesla has made considerable investments in alloy and casting technologies to enable the fabrication of bigger cast components with the potential for significant manufacturing simplification. The company rightly purchased many units of the world's largest casting machine. Hydra, an Italian die-cast firm, creates these massive, pricey equipment. Tesla's first Giga press was installed at the Fremont facility in 2020. The clamping force of the machine, which was the first of its type, reached between 55,000 and 61,000 kilonewtons at the time, which is nothing to sneeze at. Imagine a 102 kilograms person sitting on you. That's 1,000 newtons. The rest is up to your imagination. The Model Y now has 70 separate pieces that can be changed by a single rear body piece, which is a Tesla car characteristic. Tesla got many additional massive casting machines at the Giga factory in Texas, and the firm has now begun producing the Model Y. They're utilizing both front and rear single-piece casting. Hydra has been hinting about a brand new 9,000-pound Giga press that will be the largest in the world for the previous few weeks. Here's a tweet that shows the Giga press being put together. Much to everyone's amazement, Elon Musk responded by stating that the Cybertruck body was being manufactured. Given Tesla's experience with Hydra, it was expected that the new gadget would be for the manufacturer once again. Elon Musk has now acknowledged the device's use for the Cybertruck body. This is not surprising given Tesla's previous statements that the stainless steel exoskeleton body of the Cybertruck will need a new level of casting capacity. Tesla announced on its website that the Cybertruck's exoskeleton was built with a shell for optimal passenger safety and durability. With a virtually impenetrable exoskeleton as the base, every component is designed for enhanced strength and endurance, from a structural skin made of ultra-hard 30X cold-rolled stainless steel to the glass utilized in Tesla armor. In defense of what folks saw in Cybertruck's release press trailer, where the glass cracked, that model was a prototype. This massive new casting machine looks to be part of a manufacturing strategy. In order to focus on growing Model Y manufacturing, the carmaker delayed construction of the Cybertruck, an electric pickup truck that was initially exhibited in 2019. There are concerns that Tesla may miss this deadline, thus the business will now begin producing the Cybertruck in 2023. This movie depicts the construction location for the Giga, Texas facility, a 107,000 square foot plant. This new equipment is a rare indication that the company is investing in the development of Cybertrucks. So precisely what is a Giga press? Before we go into what it is, please remember to leave a like. From 2018, the Giga press machine has been featured in the Hydra's catalog with the basic standard. In order to produce the chassis parts for the Tesla Model Y, Tesla Incorporated started using a customized OL6100CS Giga press in late 2020. Shots of 80 kilograms of molten aluminum are injected into the cold chamber casting mold at a speed of 10 meters per second. 45 finished castings can be produced per hour, or 1,000 castings per day, due to the cycle time of 8,900 seconds. Using a reusable mold, the molten metal alloy is forced into it during the die casting process. Once the metal alloy has solidified, the mold is opened to allow the finished product to be removed. Robots keep things clean and cool. The open mold is heated to 185 degrees Celsius or nearly 365 degrees Fahrenheit for the following cycle, which begins 12 minutes later. Each fresh casting is roughly reduced to size before being measured and flaw-checked, prior to being shipped for CNC machining to final size. Aluminum ingots and scrap are melted to a liquid condition in a natural gas-powered melting oven at 850 degrees Celsius or approximately 1600 degrees Fahrenheit. Slag in the form of aluminium oxide is mechanically removed from the surface for Tesla's Giga press-based casting operation, and the remaining liquid metal is pumped through heated pipes to an enclosed warming oven operating at 750 to 850 degrees Celsius, or once more 1400 to 1600 degrees Fahrenheit heated by 400 kilowatts. A tank blanket of nitrogen gas keeps the molten aluminium at a steady temperature and protects it from oxide development. To eliminate contaminants, the majority of other particles bigger than 25 micrometers are removed using a silicon carbide filter and argon gas in a rotating degasser. Robots pump out the air within the mold at the start of each casting cycle to spray 35 milliliters of soybean oil in a thin layer inside each half of the mold to facilitate separation. A low vacuum of 50 millibars is created at around 1400 degrees Fahrenheit. A high-speed plunger with an extra 8 milliliters of lubricant is utilized to drive a precise amount of molten metal into the mold when it is pumped from the holding oven into the Giga casting chamber. A quenching tank is used to cool the casting from 400 to 50 degrees Celsius or from around 750 to 120 degrees Fahrenheit. A robot enters the mold and removes the casting, which is then placed in the tank after it has been retrieved from the mold at 400 degrees. The rough edges are manually chopped with a trim press, and the surplus aluminum is recycled back into the melting oven. The remaining usable section of the casting is X-rayed to verify the internal structure, laser trimmed, drilled for fittings, and precision computer measured. Yet all of this begs the issue of how this new leaf, known as Giga's turnover, came to be. So what thoughts may have crossed Elon's mind? A little die-cast Hot Wheels toy on his desk is claimed to have sparked his most recent major idea. One would think it was one of those Nolan films or manufacturing line footage, but no. Musk, who is prone to pondering what the viable size range for a die-cast car is, discovered there was no actual reason why full-size autos couldn't be built using the same design concept. It is solely his duty to uncover these sorts of competencies while constructing the dramatic model-wide redesign that would put Tesla's new generation of batteries into the chassis of the most recent cars to roll off the production lines. Musk came to the decision that the inclusion of 70 separate pieces in the rear underbody, each of which had to be screwed, welded, or somehow fastened to its neighbors, was no longer suitable. On the production floor, it's a tough and frightening procedure that takes a lot of time and energy, and it's also prone to foolish blunders. When engineering consultant Sandy Monroe, well known in the automotive sector, told Musk that the rear of his Model 3 resembled him of a patchwork quilt, he made his point extremely plain. Later that summer, the massive machines, which were 20 meters long and 6 meters tall, were installed at the company's Fremont, California facility. According to Musk, these massive Giga presses are too huge to fit in the factory and must either be immediately covered with a rudimentary shelter in a parking lot or the firm's number of robots be cut to 300. This decrease will definitely assist Tesla in terms of quality assurance and the production burden that comes with producing and assembling 70 separate parts. It was conceivable to cut the price of vehicles by putting those 70 parts together like a jigsaw, making them more accessible to consumers. Unfortunately, the CNC, or computer numerical control, procedure was time-consuming and costly. In April 2020, Elon Musk announced to the public that he had purchased two of the world's largest casting machines from the Italian engineering firm Hydra in order to make gigantic self-contained pieces, initially the Model Y's rear underbody. What do you think? Will Tesla finally start the production of the Cybertruck, or there's gonna be another delay? Let us know about your thoughts in the comment section below. Thanks for watching. Peace out.